Good afternoon, Year 7. Last week we had a look at experimental probability and we talked about how this might differ from theoretical probability. This week we are going to be doing comparing probabilities, and this will be a little bit more on comparing experimental probability with theoretical probability. So we're going to write down a key bit of information, as we usually do, which is this. You can check whether something is performing as expected by comparing the experimental probability with the theoretical probability. And if you look back in your books from last lesson, we did do an example about if you flipped a coin lots and lots of times. If you only did it 10 times, you might get 6 out of 10, say, instead of 5 out of 10. But if you did it 100, you might get 53 out of 100. 1,000, you might get 511 out of 1,000. So you get closer and closer to a probability of a half. So make sure you have this copied down in your books, please. Pause the video if you still need some time to do that. And I'm going to go on to an example. So for our example, which I want you to copy down, please, Angie throws a dice 30 times and gets a 1 8 times. Is the dice biased? So by biased, it means, is the dice weighted in some way? Has the dice been tampered with? That means it's going to land on one of the numbers more often than the other numbers. So we would expect, if it's a normal dice, there's going to be 6 numbers. So 1 to 6. And the theoretical probability of scoring a 1 on a normal dice is what? It's going to be 1/6. Okay, so if we threw a dice 30 times, we would expect to get a 1 1/6 of the time. So this means out of 30 throws, we would expect to get a 1. How many times? It'd be 5 times, because 1/6 of 30 is 5. So we would only expect to throw a 1 5 times, but we've thrown a 1 8 times. So is the dice biased? Pause the video and copy all of this down first of all, and then have a think about whether that means the dice is biased. We're going to answer the rest of the question in a minute. Okay, so what did you decide? We've said the theoretical probability of scoring a 1 is a 1/6, and so out of 30 throws, we would expect to only land on it 5 times. But we actually landed on it 8 times. So we can say the dice landed on 1 more times than expected. So at this point, we might think it could be that the dice is biased. However, 30 is not a very large number of trials. And because it's not a very large number, this means the theoretical probability and the experimental probability might not be very close together. So as 30 is not a large number of trials, it would be reasonable for a fair dice to land on 1 8 times. We can't conclude that the dice is biased. So make sure you've got all of that copied down, please, and then we're going to do another example. Before we do that next example, there's just some more key information to copy down. When we carry out experiments and we come up with an experimental probability, this is an estimate of the theoretical probability. In some situations, you'll need to decide how accurate you need that estimate to be, where your estimate is the experimental probability, you're estimating the theoretical probability. The more trials you carry out, the more accurate your estimate of that theoretical probability will be. For this example, I'd like you to pause the video to copy it out. I'm going to read it to you first and then copy it out, please. So a knitting machine in a factory usually produces no more than 2% of jumpers which are defective. So 98% of the jumpers are absolutely fine and can be sold. However, a manager sees that a batch of 20 jumpers has 2 defectives. Should she stop production and have the machine examined? Now, we've just said that we need to decide how accurate our estimate is sometimes. So sometimes we need to decide if our experimental probability is accurate enough and if it's a good estimate of the theoretical probability. And that's what we're going to need to do in this question. So pause the video and copy this down, and then we'll talk about this question and then we'll answer this question. So in this question, we've got a knitting machine and it usually produces no more than 2% of jumpers which are defective. Now, a manager sees that a batch of 20 jumpers has 2 defectives. What this means is the manager's experimental probability is equal to 2 out of 20, which is 10%. So that's the first thing we should notice. The experimental probability is 10%. Now, our experimental probability just going to switch pens because that one's running out a bit, of 10% is much higher than the theoretical probability of 2%. Now, there's a couple of things to consider. Is our experiment big enough to be an accurate estimate? And is 2% possible when we've only tested 20 jumpers? Two percent of 20 is 0.4 jumpers. And it would not be possible for only 0.4 jumpers to to be defective because it has to be a whole number of jumpers. In fact, the minimum percentage, well, there could be 0 defective jumpers, but out of 20, the minimum you could have is 1 defective, and that would still be 5%. So what actually should happen is, instead of the manager stopping production and having the machine examined, the manager should check more jumpers. Then, if the number of defective jumpers still remains higher than expected, that is when she should have the machine checked. Okay, so make sure you've got all of that copied down, please, and that should now be enough for you to have a go at the question sheet that I've put up. If you struggle with any of the questions, please let me know and I will put solutions on Show My Homework.